Alright, so this video is on inverse trig functions. And so how do we determine what the inverse function of this is? Well, somebody made that up. Somebody, like I always say, old men in sandals, made that up. They determined what it was going to be called, and they said it was going to be the inverse function of sine. And so we're going to quick draw y equals sine x. And I want to kind of have more than just one period, slightly more. I guess I kind of want it to have a little bit of this too. And so if I'm trying to determine the inverse function, if you recall from previous courses or previous topics, one of the first things we do is we switch x and with y, and then we solve for y. But I do want to talk about this for a second. We're not actually switching the x and y itself. It's not. We're switching the labels. So this is still just a number. It's not my angle measure. I'm just switching the values. This is an angle measure. And so I'm now, for this green function, the angle measures are up here and the numbers are down here, so that it's within convention where independent, dependent variables, etc. Okay? So once I do that, I have to undo this sign, and what I do, based on what the old man in sandals said, we're going to have this function called inverse sine. I'm going to take the inverse of both sides, the inverse sine of both sides. Oops, that's a 1. Of sine y. And what that does for us is these undo each other, and I end up with just y by itself on the right-hand side, and I have this thing over here, inverse sine of x. And so a way to see this is I'm going to take the inverse sine of a number, square root of 2 over 2 for instance, and it's going to tell me an angle measure. Okay? So we take inverse sine, cosine, tangent, secant, cosecant, cotangent to determine the angle measure that goes with this particular number. All right? Where, for instance, over here, I took the sine of an angle to get a number. So let's erase all this stuff. And I get, so I'm back over here at the inverse sine of x. Now, because I switched the x and y, we have to think about graphically what does that mean. And so I have this function, y equals x, and inverse functions are reflected about that axis okay? But the problem with that is this new function no longer passes the vertical line test. And you may have noticed that before when you think about horizontal line tests that we talked about previously or in a previous topic. But that's a problem, because then when I take the inverse sine of some number, I get an infinite number of responses or an infinite number of answers, which doesn't help me. So it sort of makes the function somewhat useless. There's an infinite number of values that could satisfy that. So it's not super helpful. So the old men in sandals said we have to restrict this. Now, for instance, they could have said let's restrict it from here to here, but it still doesn't pass, right? If they said, okay, we could restrict it from here to here, then it would pass, right? It passed the vertical line test, but, to be in between here. But we don't like that one because it sort of doesn't make sense. It could be completely arbitrary, but they chose to center it around the origin. And so the inverse sine function has a range restriction of pi over 2 down to negative pi over 2. And of course its domain, because of the range of the sine function, this is going to be negative 1 to 1. So inverse sine is restricted to be between negative pi over 2 and pi over 2. Okay? What does that mean for us in practical use? So let's draw this over again down here. And let's draw the unit circle a little bit. I can make a decent circle. I can make a decent circle, but not a decent line. Okay, that's not too bad because I'm using that software. And so that's not too bad. So again, we'll draw this. It looks like this. And this goes between pi over 2 and negative pi over 2 on the y-axis, and is negative 1 and 1 on the x-axis. Well, how does that correspond to the unit circle if it's helpful for people to view it that way? That means when I take the inverse sine of any function, I'm only going to get values between here and here. So for instance, if I go back to that example, y equals the inverse sine of radical 2 over 2, hopefully we know at this point that radical 2 over 2 corresponds with pi over 4, or some pi over 4 reference angle. Well, pi over 4 as a reference angle is that or that, right? Because this height is square root of 2 over 2, and this height is the square root of 2 over 2. But it cannot be this one. Why? Because it's not in our restricted domain for sine, so it has to be this guy. And it can't be any multiple of pi over 4 because any other multiple is not between negative pi over 2 and pi over 2. All right? So that's what we're talking about when we're talking about inverse functions, that they are restricted in their range. All right? So let's slide up from here. Well, that's long enough. We're going to stop there, and then there's going to be a second video on the restrictions of all the other ranges for the other functions. All right? That's it. Bye.